Hello and welcome to today's GFG problem of the day. Hope you're doing extremely well. So let's see today's problem, tree boundary traversal. Okay, so what the problem is saying is we'll be given a binary tree and we want to find its boundary traversal. Okay, the traversal should be in following order. So first then it should be a left boundary. Then we would need to process leaf nodes and then the reverse right boundary. Okay, so what does it mean is, so what is a boundary first of all? So boundary is this. This is the boundary. Okay, like for example, these elements are the boundary elements. Okay, so here if you see, let me draw this like this. Okay, so these are the boundary elements. What are the boundary elements here? 1, 2, 4. Then, so these are the left nodes. Then we need to process the leaf nodes. So what are those leaf nodes? 6, 8, 9, sorry, 6, 8, 9, again 6 and 7, right? So these were the leaf nodes. Then the right elements. These are the right elements, right? So 7 was part of leaf node. So 3 is the element. So this is a boundary traversal of a binary tree. Okay. So I hope you have got the problem. Okay. Now, what the problem is saying is we have been given three conditions. Okay. So first is we want to process the left boundary. Okay. So what does it say? This includes all the nodes on the path from the root to the leftmost leaf node. You must prefer the left child over the right child when traversing. Do not include leaf nodes in this section. So, okay, so what it is saying, the nodes should be right from the root. This is the root, right? The root till the, okay, to all the elements of the left side. Okay, so these are the elements, right? Which it also says that we don't have to include the this leaf node. That's what it is saying. Do not include leaf nodes in this section. Okay, so these will be the elements 1, 2, comma, and 4. The leaf nodes are all leaf nodes in left to right order that are part of the left or right boundary. Okay, so all the leaf nodes. So these are the leaf nodes. Okay, so 6, 8, 9, 6, and 7. So these are the leaf nodes. Then reverse right boundary. This includes all the nodes on the path from the rightmost leaf node to the root, traversed in reverse order. You must prefer the right child over the left child when traversing. Do not include the root in this section if it was already included in the left boundary. Okay. So here what it is saying. So we want to have these elements. Okay. In this case, it will be this element only because this one is already part of leaf nodes. Okay. So this will be on the right boundary. This will be the element and not root because root was already included. Okay. So the last element or the element on the right boundary will be only 3. Okay. So this is the ask. Okay, now let's go and code. I think you'll understand better. So before going to the code, I'll just request you please subscribe to the channel, like the video. So first I show the Java code followed by C++. So we'll take first a list, integer result equal to new array list. Okay. Then we will write boundary left traversal, we'll say. Okay. So first of all, so we are going to pass a root node data. Okay. And since we don't want to include, since we have included root node in the result already, so we will go to the left, and we'll also pass the result. Now let's void boundary left traversal. Let me copy this. Boundary left traversal, node, and array list, integer result. Okay. Now, first of all, the base condition. What the base condition will be? If node equal to null, simply return. We could have written this later on. You would have understood. Return, simply return. Okay. Now, what we want to do is we don't want to include the leaf node. Okay. What the problem is saying is we want to include all the elements right from root to the node on the left side, which is not a leaf node. Okay. So till these elements 2 and 4. So what are we going to do? So we need to check. It should not be a leaf node. So if node dot left, if it is not null, then that means it is not a leaf node. Okay, so we will add here. So node dot data. So what we adding here? For example, let me quickly erase everything. Yeah. So first, what we did, we added this root node in the result that you know. Then we passed this particular node, root node dot left. That's what you're seeing here, right? So first we added the root node data into the result list, and then we are passing node dot left, okay, into this boundary left traversal. And what we're doing here is, if node dot left, so node dot left we passed, okay, node dot left. What is node dot left here? Node dot left is nothing but 2. Okay, now what we're doing, if node dot left is not equal to null, then we are adding 2 into the result list. We have added 2 here. Okay, then we want to run reverse again, we want to run the recursion. Okay, and we'll pass this node dot left again. Okay, so let me call this. Okay, so what will pass? Node dot left, comma result. So what we're passing here, node dot left means this particular. We are passing 4. Okay, again, we'll check here. We'll come here again. Node dot left is not equal to null. Yes, it is right for 4. 4 dot left is not equal to null, right? So we'll add 4. Result dot add 4. So we are adding this. Okay, we are adding this, right? So this will take care of all the elements on the left side of all the left side elements. Okay, okay. But what if the case, for example, let's see, let's draw uh, this one. Okay, for example, if this was the case, 1, 2, then 5 and 8. Okay, there were no left elements of 2. Okay, there were no children of 2 here on the left side. Okay, so if this was the case, for example, and this some subtree, right? So what will be the left boundary here? Let me also draw, for example, you'll understand better. Okay, so 6 and 7, if this was a tree. So what is the left boundary? So the left boundary is this: 1, 2, 5 and 8. So 5 and 8, despite being 5 and 8, despite being right children of 2, but still it is a part of left boundary, because there are no elements, or there are no children on the left side. There are no left side children. Okay, and that is why 5 and 8 are the left side elements. Okay, so we need to write the case for this as well. For example, if node dot left, for example, node is 2, and node dot left in this case, node dot left, if node is 2, if node dot left is nothing, right, then we need to check for the node dot right. We need to check for the node dot right. Okay, which is that? Which is this one. So what we're going to check, if node dot right is not equal to null, right? That means we want to result dot add will node dot data first, which is we are adding 2, and then we are going to pass what? Again, we are going to call boundary left traversal, node dot right we are going to pass. Okay, result. So what will happen now? So we will go down. We are passing this 5. Okay, okay, and we are going to print this particular element. If this was the case, for example, what would be what would have been the left side elements? 1, 2, 1, 2, then 5 we have added, right? 5 we have added, and then we'll go to the left side of this one, right? Left side of this one, which will be 8. Okay, so we have added this condition as well. Else, I hope you have got this condition. Okay, so this left side we are done. Okay, and these also make sure, right, that the leaf nodes are not added, because node dot left is not equal to null, node dot right is not equal to null. There's no scope for leaf elements wherein left and right both are null. Okay, so now what we are going to do? We are simply going to implement now or traverse leaf nodes. Okay, leaf traversal. A bit big name for a function, but still okay. So now we are going to pass the node, which is the root again, the top one. So let me now control void node array list integer result, right? Now if again, so what we're going to do here now, we're going to check, we want to add the leaf nodes, right? If node dot left if is equal to null and node dot right equal to null, That means result.add node.data. Okay, we want to, that means it's a leaf node and we want to add the leaf node. Okay, and what we're going to do, we are going to simply do the left and right traversal in order to find all the leaf nodes. Okay, node.left result, node.right result. Okay, and what will be the base condition? If node equal to null, this will be the base condition, return simply. Okay, so we are done with this leaf node traversal as well. So we are adding only if we are adding the elements, the element data only if it's a leaf node. Okay, okay, I hope you have got this. Now the third part is the right traversal, right boundary traversal. Okay, boundary, let's maybe for this function at least, right traversal, let's make it short, it's very big. Node result, right? And void right traversal node array list integer result. Okay, now what we are going to do here is, since we want to process the right nodes, right? So first of all we are going to check if node.right is not equal to null, we don't want to include the leaf node, that is why node.right. So here in this case we are going to keep on going to the this to right, keep on going to the right. Okay, result. Now let me explain this what we are doing here. Let me first write the code. Result.add node.data. What will be the base condition again? If node equal to null, simply return. So what we're doing here is, for example, if this is the node, right? So we are passing what? We are passing what? In the right traversal, we are passing the root node. Okay. So what we have to do is, okay, first of all, we don't want to include the root node, right? So we're going to pass root dot node dot right. What we're going to pass? We're going to pass this node dot right. Okay. If this was a case, for example, let's call it, there was some one more element. Okay. So what we're doing, we are passing this particular element to the right traversal. So what we're doing here is right dot traversal, right? So if now here, what is a node? Node is 3 here, right? Node is 3. Let me take another color of pencil. Okay. So node here is 3, right? And what we're checking here is if node dot right, if node dot right is not equal to null, what is node dot right here? What is node dot right here? What is wrong here? Okay. So what is node dot right? Node dot right is 7. Okay, it is saying, okay, there is some element at the right side of 3. Okay. So we are again doing the recursion. We are again going to the rightmost, right? Because why we're going to rightmost again, we are not adding in the result list because we want to add the elements from bottom to top. Okay. And that is why. So here we came to this particular node now. Okay. We came to this particular node. Again, we are going to check, is there right side element of 7, is there element on the right side of 7? Yes, it is there. Okay, so just go again to 9, but 9 dot right and 9 dot left both are null, so we are going to go back. We don't want to include this 9 because it's a leaf node, right? It's a leaf node. So now we are going to dump 7 now. Okay, once it is done, we are going to see we are adding 7 now to the boundary element. So what is the boundary element till now? 1 2 5 8 6 and 9. Now we are on this element, we are going to print this 7, and then we are going to print the elements or traverse elements in the reverse order. We are going to dump the elements in the list in the reverse order because we want to go this side in this way, right? This is the order 7. Now we are unstacking the tray is the stack, right? Okay, so we are unwinding the stack. So for example, it was 7. Now we'll go back and then we are going to dump 3, right? That's what we are doing. First, we are going recursively on the right side. Once we hit the base condition, right, or we don't hit this particular condition, then we are going to unwind the stack. And while unwinding, we are going to add the element. I hope you got this. Now again, we want to add another condition. Let me explain this. If node dot left is not equal to null. Okay. And then again, what we want to do, since we want to print the elements on the reverse way in the reverse traversal. So first we are going to go to the leftmost, and while stack is unwinding, we are going to add in the result. I hope you are getting this. Node dot data. Okay. So let me explain this particular condition. So why we are doing this. For example, if this was the case, 1, 3, okay, then we had 6, then we had 7, and we had 8, right? Or maybe like this, 7, right? And we had 2 here, we had 4, we had 5. So this is binary, right? This can be anything. We had this 8 and sorry, let me write 8 and 9, right? But on the right side, what is the right boundary element? Right boundary element is this, right? Is this. This particular is the right boundary element, right? Because there are no elements here, right? There are no elements here. And that is why the right side elements, the right boundary is these elements only. And it can be on the left side, right? See if it is on the left side. And that is why for 3, there's no right element. There are no right children. And that is why this condition comes into picture. Node dot left. If node is 3, node dot left is null. And hence we are going to go on the left, keep on going on the left side. Okay, keep on going on to the left side. 6 and 7. 7 will be leaf node, will ignore this. And then we are going to unwind the stack. We'll come to 6. We are going to dump 6 here. Then we'll go to unwind the stack again. We are going to get 3 here. So we're going to keep on dumping in the list. Okay. So I hope you have got the problem. Now, let me compile this. Let's see it works. Okay. There are some errors. Nice. So what is the error? Node dot left. Where is this? 110. Let's check on 110 line. 110, 110. What is the issue here? Is this the issue? I hope so. Let's compile again. Yeah, we have one more error. Class integer. Where is it? Okay, must be the bottom. Okay, my bad. Typo. Compile an error. Let's compile this. Okay. Finally, we want to return result. Return result. Okay, it is compiled successfully. Let's submit this. Thanks for watching. I hope you've got the solution. Please don't forget to subscribe to channel, like the video. Okay, there's one more case we want to handle. So what this case is, for example, so here, right, it is only one node, which is a root node, which has one. Okay, rest null means there are no left child and right child. So for this, you have to handle specially. So what we're going to do, if node dot left is equal to null and node dot right equal to null, then simply return result. Result already has this root data, right, which is 1, right? That's it. Just simply return result from here. Let's compile this again. Okay, I'll quickly show the C++ code as well. Okay, the test cases are being processed. Okay, thanks for watching. Please subscribe to the channel, like the video. Let's quickly see the C++ code. Here's the C++ code. Okay, so let's go down. Okay, so here what we did, we took a vector, right? Here, for example, if node is null, extra check, right? We'll return result. Okay, we are adding the root element here. We are checking if it is a leaf node only. If it is only one node, we are going to return the result here. Then we are going to print. If it is a complete binary tree, then we are going to first add up all the left, all the elements of the left boundary, then leaf boundary, then all the leaves, right? And then the elements on the right boundary. So let's quickly go and do quick walkthrough for the left one. So here base condition, we know this. Here if node dot left, we are going to prefer this one. We are going to add the element first. Then we are going to go and traverse the element recursively on the left side. Okay, we're going to go on the left side recursively. Okay, and for example, if there are no left child, then that means there's a right child, and that will be on the left boundary. So we are adding that, and again we are traversing the right children. Okay, similarly here, what we are doing here is we are adding up all the leaf elements. Okay, we are going left and right subtree, we are traversing those. Okay, and then comes the right boundary. If it is the right child, we have to prefer that first, and we'll keep on going to the right side because we want to have the elements right in the reverse way from the bottom to the top, and not include the root node, right? So here we are doing the same. First we are traversing, and then we are pushing back the elements in the vector. Okay, that is where when we are inserting the elements, when the stack is getting unwinded, then we are doing this. Okay. Similarly, if there are no right child, then there are left children. That means they are on the right boundary. Okay. So this again, I have explained this, and then we are adding the elements when the stack is getting unwinded. Okay. So finally, we are returning the result. Thanks for watching. I hope you got the solution. I'll attach the code in the description section. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.